Hello, this is Anand Paul and welcome back to STAAD Pro v8i Advanced Training Series. In this session, we'll learn how to calculate the frequencies of a structure. In STAAD, there are two methods to calculate the frequencies of a structure. The first method is called the Rayleigh method, in which we use calculate Rayleigh frequency command to obtain the frequencies of a structure for a specific loading. And the second method is an advanced method, which is called the eigenvalue extraction method, in which we calculate the mode shapes of a structure to obtain the frequencies. The Rayleigh method in STAAD is a single-step approximate method from which we will obtain a single frequency value for the loading that we have provided. STAAD Pro will calculate the frequency value for each and every loading that we have provided in the load case definition. The program uses the displaced shape of the model to obtain the frequency. So it is extremely important that the displaced shape that our loading can cause should resemble the vibration modes for which we are trying to calculate the frequency. If you are interested in calculating the fundamental mode or the fundamental frequency of the structure, the loading to the model should cause a displacement in the model corresponding to the fundamental mode shape of the model. For example, the fundamental mode of vibration of a tall building will be a cantilever style mode, where the buildings face from left to right with the base of the structure remaining stationary. The type of loading which will create a displaced shape that can resemble this mode is a lateral force, such as a wind force or a pressure in lateral direction or loading in lateral direction. So in Rayleigh method, the loads which we apply will be always in lateral direction and not in vertical direction. Before using calculate Rayleigh frequency command, it is very critical to define the density command, since the mass of the structure is one of the critical components of frequency, and for a structure the mass comes from the self-weight. So if you are using the self-weight command, it is necessary to define the density command that will be used to calculate the self-weight of the structure. By default, the density command is auto-generated while we define the material. So if you are using concrete material, the density command is automatically generated in the STAAD file. In this video, we will try to calculate the fundamental frequencies of the building in both X and Z direction. So we will be having two load cases, one in the X direction and the other one in the Z direction. I have labeled the dimensions of the building, and all the four supports are fixed supports, and I have assigned the dimensions of the columns as 0.4 by 0.4 meters and the dimensions of the beams as 0.4 by 0.3 meters, with a material defined as default concrete definition in STAAD. Now let us move to the load and definition option, and we will define the load cases to calculate the frequencies. Click on add button to add the first load case. Select first load case and we will assign a self-weight load in positive X direction. So the factor will be 1. You may notice that the factor provided is positive 1. To calculate the frequencies, it is always advisable to use positive values, since negative and positive values together can confuse the STAAD Pro and can cause errors during the analysis. So we will add a self-weight in positive X direction, and we will add a flow load in positive X direction with a magnitude of 3 kN per meter square, which will correspond to the dead load on the floors and the roof, with Y range of 0 to 16.5. Click add. Now we will apply the self-weight to the view, which will apply the self-weight command to the whole structure. After defining the loads, we will add Rayleigh frequency command to calculate the Rayleigh frequency using Rayleigh method. This looks like a load item, but it is a command to calculate the Rayleigh frequency. Similarly, we will add next load case in order to obtain the frequency in Z direction. We will apply a self-weight in Z direction with a factor of 1, and same flow load in global Z direction with a pressure of 3 kN per meter square for Y range of 0 to 16.5. Click add. Again add frequency command using Rayleigh frequency method. After defining loads, we will add analysis command. Now our structure is ready to be analyzed. We will go to analysis menu and click Run Analysis. Let us check the output file. We will scroll down to find two values. Here we can see the calculator Rayleigh frequency value for loading 1, that is 1.49 cycles per second, which corresponds to a time period of 0.68175. Similarly, STAAD has calculated the Rayleigh frequency value for Z direction, that is 1.418 cycles per second with a maximum deflection of 15.75 centimeters in global Z direction, and the maximum displacement has occurred at joint 10. So this is the simplest way to calculate the Rayleigh frequency or the frequency of a structure. We are having a good idea about the loading definition that can resemble a displacement pattern corresponding to the fundamental mode shape of the building. In the next video, we will learn how to calculate the frequency of a building using eigen extraction method, and we will compare the value of frequency obtained in the eigen extraction method and using Rayleigh frequency method. So this concludes this video. Thank you for watching the video. For more videos and updates, subscribe to our channel Online Civil Digital.